Today, Algebra, we're kicking off our new unit with CO53, just kind of talking about the different characteristics of what a parabola is, what it looks like, and how we can use these different pieces to solve for things that we want. So the start of this is going to be a bunch of definitions. Being as these are definitions, they are eligible for your definition quiz, which will be coming up in, not next week, the week after that. So make sure that you are not only getting these definitions down, but that you understand what they mean, right? So a parabola is the graph that we get from the equation y equals ax squared plus bx plus c, okay? As you progress through algebra, you'll see that there are many different types of graphs, and each type of graph comes from a different type of equation. Like what graph comes from slope-intercept form? We talked about this one earlier, y equals mx plus b. What type of graph comes from that? What's it going to look like, Elliot? Linear graph, right? It's going to be a straight line, okay? So whenever you see an equation in that form, you know what the graph is going to look like. What characteristics it has. It has a slope, it has a y-intercept, right? It's a line. When you see an equation in this form, which your experience with this has been factoring, you know it's going to look like this, okay? Some sort of parabolic shape. And what gives it that parabolic shape is this x squared term, right? When you get to algebra 2, you'll start to graph like x cubed equations, which look like that. Kind of neat. You'll graph square root equations, which look like that, kind of half of a sideways parabola. You'll graph absolute value equations, which look like these, okay? So every type of equation has a graph that kind of goes along with it. And this unit is going to focus on parabolas. We talked about domain before. Who remembers what the domain of a graph is? Yes?
Is it x?
The x values, okay? And for our purposes, since all parabolas have this U-type shape, and those arrows on each end, it goes on forever, the domain of every parabola that we're going to work with is all real numbers. Remember, that's the symbol for it, okay? That's the symbol for all real numbers, right? Since parabolas go on forever in both directions, that's a mathematical symbol for it. What is range? What is range again? Yeah, Max.
Y values.
The y values, and that's going to kind of vary depending on what your parabola looks like. So we'll just put the actual definition of it: the y values of the parabola. Okay. Now, one of the characteristics that parabolas have is that they're symmetrical. Right? If you kind of fold the parabola over onto itself, these two pieces will match up. And the middle of a parabola is called the vertex point. Okay? It's the middle point of a parabola. It's also the highest or the lowest point. That's kind of how you can identify it. It's where that curve happens. Okay? That's called the vertex point. The middle point of a parabola, the highest or the lowest point. And finally, the last characteristic, the axis of symmetry. The axis of symmetry is an imaginary line that goes vertically. I'll get all the way in a second. Vertically through the vertex. An imaginary line going vertically through the vertex. Basically, it's called the axis of symmetry because that's the spot where you can fold the parabola over and it's going to land on itself. So it's kind of like it identifies, like the vertex, the middle of the parabola. Okay. Questions so far? Yes, Rowan.
Why does it say all real numbers? Or fake numbers?
There are. Well, they're not called fake numbers. They're called imaginary numbers. Okay. Basically, because math teachers need something to teach, otherwise we don't have a job. When we run out of concepts, we just imagine things, and so they came up with imaginary numbers. Actually, you know what? Some of you might get this on your map test. Let's actually take a tangent and talk about this. So, you know that the square root of 9 equals 3, right? What about the square root of negative 9?
Negative 3.
It doesn't have.
Okay. Here's the problem with this. The definition of a square root, right? We want what times itself equals 9. That's why 3 times 3 works. But negative 3 times itself
Also be
is also positive 9, right? So when you have the root of a negative number, we run into a little bit of a problem here because nothing times itself is going to equal a negative number. Yeah.
Does that mean it's undefined?
It doesn't mean it's undefined. It means that it's imaginary. We imagine what the answer is. And so if you ever see the answer to this is 3i, and that little lowercase I means that it's not really 3, but we're imagining it is. It's kind of trippy.
I think that's fake.
You'll get more of this in Algebra 2, but some of you might see this pop up on your math test. If it asks you for the square root of a negative number, okay, it's what the root is, what you think it is, 3, followed by an I, right? And then if you're asked to like combine I terms, like if you have 3i plus 5i, you treat it just like any other variable. That'd be 8i. Okay, that lowercase I is specifically designed to define an imaginary number.
Why wouldn't they just do 3 plus 5?
Because what they're saying is that the imaginary value of 3 and the there's. So thank you, Rowan. That was pretty fun. Other questions? Okay, so going down to actually identifying and labeling these. Says for each parabola, I identified the domain and range, each written as an inequality. Okay, and I'm going to adjust that slightly. The vertex, the axis of symmetry, and the minimum or the maximum point. So this is the same parabola you saw up the top in the corner. We already said that the domain is going to be everything. Okay, those are all real values there. What about the range? What y values are included in this parabola? What do you think, Elliot? Sorry? It's going to be, because one would be here.
Oh, sorry, greater.
And there are some values below that. Basically, what you want to look for is that vertex point, right? And since this parabola is opening up, it's never going to come back down again. So 0 is the lowest y value of the parabola. Written as an inequality, as Elliot said, it's going to be y is greater than or equal to 0, because 0 is included in the parabola. Okay? Going up the y-axis, everything greater than or equal to 0 is going to be included at some point, because these arrows indicate it continues going on up forever. What's the vertex point? That curve, that middle point? Yeah, 0, 0. And it does need to be written as an ordered pair, because it is a location. Now the axis of symmetry, like I said, it's an imaginary line. It's not actually visible. But if you imagine a vertical line going through that vertex point, right? That point, can't really see that. That point where, or that line where if you were to fold the parabola over, it would land on itself. What's the equation of that vertical line? Where does it cross the x-axis? 0. So the equation would be x equals 0. Okay? X equals 0. Minimum, maximum. This tells us whether the parabola opens up or opens down. Obviously, you can just look at it and see it. Okay? But that vertex point is at the minimum point or is the maximum point? The lowest point or the highest point of the parabola? It's the minimum, right? Okay. So there you go. All right. Those are kind of those 5 characteristics that we'll be referring to as the unit goes on. And why is because it's the lowest point. That's the minimum value. So if you're told that a vertex is a minimum, that means the vertex is the lowest point, your parabola will open up. If you're told the vertex is a maximum point, that means it's the highest point, you know the parabola will open down.
Oh.
Okay? If you have the graph, you can just look at it, but if not, you can use those words to help describe it. Yeah?
For a parabola with domain, will it always be all imaginary?
For our purposes, yes. Not all imaginary, all real numbers. Yeah. For our purposes, yes. When it won't be, or like when you're dealing with parabolas in context, so you want just a certain part of it, not the whole thing. But for our purposes, just defining for these parabolas, yes, it'll be always all reals. Other questions? All right, going on to the next one. Domain, again, all real values. What's the range of this one going to be? Look at those y values. Claire.
Y is less than or equal to 6.
Good. Y is less than or equal to 6.
What is it?
Y is it what?
Why is it
6, because if you look at the y-axis, we see that at 6, that's the highest point of the parabola. So everything below 6 is included because it continues to go down. But because it never comes back up again, right? It's not going to go back up around. Everything above 6 is not included in the parabola. Vertex point. Vertex point. 0, 6, that highest or lowest point. Okay. The axis of symmetry, that imaginary vertical line going through the vertex. Where does it cross the x-axis? 0. So it's going to be x equals 0 again. All of them will not be 0. It depends on where it crosses the x-axis. On the next one, our vertex is not on the y-axis, so it's going to be a little bit different. But we're starting a little bit simplistic. And is this a minimum or a maximum point? Maximum point, right? That highest. Okay. Questions so far? Okay. Looking at the first one on the next page, our vertex has moved off of the y-axis. The domain, though, is going to remain the same. All x values are included in the parabola because it will continue to expand wider and wider. Everything will be a part of it. What's the range of this one? What y values are going to be included? Alex?
-8y greater than or equal to
Good.
-8.
Y is going to be greater than or equal to -8. -8 is that lowest point, right? So everything above that on the y-axis is going to be included. Vertex point. Vertex point, Max.
3 -8.
3 -8. Okay. And axis of symmetry. This time it's going to be much easier to see since it's not on the y-axis, right? That imaginary line going right through the center of the parabola through the vertex. Kylie? X equals 3, right? What we're looking for is where does it cross the x-axis? X equals 3.
Oh, great.
And is that vertex a minimum or a maximum?
Maximum.
Yes, if it's upside down, it would be a maximum point, but it's not, and so it would be a minimum point, right? It's that lowest point of the parabola. That tells you that it opens up. If the vertex is at the bottom, it has to open up. Now that our vertex is off the y-intercept, off the y-axis, we can see some connections a little bit more easily here. Anything pop out at you, Andrew?
Well, for the next one,
Let's not get to the next one yet. Let's save that one. Anything pop out at you? Any connections, any relationships that you can see between what we have here for this particular parabola? Kylie?
the vertex is basically just that symmetry in range.
Exactly. That vertex point tells us a lot about the parabola, right? Notice that the y value of the vertex matches the y value of the range. Notice that the x value of the vertex matches the axis of symmetry, right? So knowing, for example, that the vertex is 3, -8, and it's a minimum point, not only does that then immediately give you what the range is, you know that everything above -8 is going to be included, but it also gives you that axis of symmetry value also. Okay? That vertex is a very informationally packed point. Okay, Beckman, what you got?
For the next one, it goes a little bit over the x-axis.
The vertex point?
Yeah.
Yeah, so what would this vertex point be here?
0.25.
Sure.
0.5.
0.5?
No, it's not even close to 0.5.
Well, so the vertex point, it wouldn't be 0.25 because that'd be on the y-axis. So where is it between 1 and 2?
1.5.
1.5, and then if you want to put 0.25, fourth up. If you did put 0.5, I'd accept that. I mean, it's kind of in that general area there. But the point is, yeah, a vertex point doesn't always have to be on an integer value. It can be a fraction, can be a decimal. Okay. All right, lesson's done. We can go back to playing our computer games. Oh, she left. Never mind. Maybe.
Is that a 0 or
Yeah.
parentheses then 1?
Sorry, it's parentheses then 1.
Oh,
You telling us, like,
No,
are you
hey.
telling us
Hey.
the computer games is permanently recorded on you?
I know, that's right. Nice, no one watched my
Can we
videos
actually
anyway.
play games?
Nice job,
I do.
folks. This is why I pick you to be observed, because you
picked
participate.
us,
we
we
observed.
3 donuts, now we get.
Let's not push it.
Should have done
I
the
gave you
other
compliments. That should be.
This is like
Yeah.
we
We
still
still
get
get
our
our
Let's finish up. What's the domain?
All real numbers.
All real numbers.
Is it always going to be all real numbers?
Yes. Just yes.
Let's go, easy stuff.
See how easy it is when you actually listen and pay attention.
We
though?
do listen and pay attention.
Some of you always do.
I
Some of
listen
you.
to
You know.
Don't
What's
come
the
over.
range? What's the range of parabola? Now that we've got the vertex point, the range should be a piece of cake,
Oh,
Wait.
right? Because then what the vertex tells us, okay?
I'm still tripping up on how you get the.
y is less than.
Hold on. Pretend like my boss is still in the room.
I still don't get why it's greater than less.
So what that tells you, y is less than or equal to 0.25 here, because if this is the 0.25, right, that's the vertex point. Notice how the y values are all below that, right? The parabola opens down. Okay, no y value above the vertex point is part of the graph, right? Only the y value is below it. So if the parabola opens up, it's going to be a greater than or equal to because everything above, right? Is open up. Axis of symmetry. What's the relationship between the vertex and the axis of symmetry? Ellen.
It's x equals 1.5.
X equals 1.5. And is that a minimum or a maximum point? Maximum, right? It's the highest point. It's the highest value on the parabola. It is the maximum y value that it has.
If it was upside down.
Don't pretend to upside down.
Turn around and time.
Okay, the next two, you need to sketch a parabola based on the characteristics. Folks, Jack, sketch a parabola based on the characteristics. I'd start with the vertex point, and based on the range and the minimum maximum, that should tell you which direction the parabola opens. If our vertex point is at 4, 3, and it's a maximum point, and the range says the y values are below it, what direction is this parabola opening? Down. Okay. Now, what you don't know is how thin or how wide the parabola is. That's not so important yet. I don't care about that. What I care about here is vertex and direction. So as long as you make it more or less symmetrical, right? It doesn't have to be perfect.
I
That's
don't
why it's a
think
sketch.
that's symmetrical.
That actually is looking quite swell. Okay. All right. Your homework for Tuesday is to finish this page. You got one left to do, and on Google Classroom, there's an exit quiz I would like you to complete that as well. So log into Google Classroom. There's an exit quiz. It's 5 questions. Won't take you long. Maybe it's only 4. Do that now. Yes, thank you, Aiden. That would be most correct. Okay. So, what? No, okay, Google Classroom for the quiz, exit quiz. Finish that up, and then you can